we can actually hide this. Let's hop back over here. We don't need this, and let's open up the chat. Put the chat. Chat usually goes here. Okay. Yeah, sorry for the late start. Just did the best that I could. Just running late. Just yeah. So running late. So but that's it. So we got about the maybe shy of maybe 10 minutes of what we normally would. So let me see. If I want to divide this up, maybe over 3 days, 42. So that's a 1, 12, 14 slides a day. About 14 or 15 slides a day is fine. Okay. I'm just trying to get a sense of how many we need to touch on to be on track, right? So I hope everyone had a great weekend. This should be week 6, I believe it is. And actually, let me do this. I just realized this isn't the right file. Edit like this. I want to duplicate this one. Go ahead and change the title. So this is week 6, 1.5 transformation of functions. This is college algebra. We meet Monday, Friday, 4 p.m. Tuesday, Thursday, 3:50. Yeah. Okay. Oh, this is fall of 2020. Man, 2020 has been a hell of a year. Anyway. All right, so we really just need to get through about 15 slides to be on track for today. We got 20 minutes, so it's totally doable. We can go over a little bit, but yeah, we'll do the best we can. So again, I am monitoring the chat. Okay, the little table. Lakers in 4. I'm not sure what the little table is. If it's in the homework, make use of the Ask My Instructor. So use the Ask My Instructor, and that'll send me a screenshot, and I can give you context on the homework questions. Okay. So in this section, we want to take those basic functions that we were working through last time. So I think we had like the identity function, squaring function, which is like a parabola, all those basic functions. And we want to look at, we want to take it a step further and look at transformations on these functions. All right. So then a new function is formed by performing certain operations on a given function f. Then the graph of a new function is called the transformation of the graph of f. Right? So say we had f of x was the absolute value of x, and then g of x we basically added this 2 on the outside and we subtract 3 on the outside, right? So we have the basic function absolute value. So remember the graph of absolute value is like a v, and let's see how these two transformations or manipulations, how it affects the original graph, right? So we can start by making a table of values and graph the equations, right? So here we have our basic function, y equals absolute value of x. And then we'll take the first function where we add 2, right? So we just chose some values of x. Now, I don't know if this is the table that you're referring to, but this is just like a chart, right? We're choosing some x values, finding the corresponding y's. I don't know if the table was maybe sports related, but yeah, so we just chose some values of x, and we're going to find the corresponding y values, all right? So notice the absolute value of -5 is 5. Then if we add 2 to that, we get 7. Absolute value of -3 is 3. If we add 2, we get 5. So on and so on until we finish the list, right? So then the blue was the original, the red is the new. So notice, how could you articulate, how do we change from the blue graph to the red graph? What changed? If we look at the image, right? We added a 2 on the outside. How do we go from the blue to the red, right? So notice the red it's the exact same as the blue. We just moved it up by 2 units. All right, we moved it up by 2 units. All right, so if we add a positive number on the outside of our basic function, it's going to move it up by a factor of 2. So if we add a positive number on the outside and it moves it up, can anybody anticipate what do you think happens if we subtract a positive number on the outside? What should happen? If adding a positive on the outside moves it up, what do you think happens if we subtract a positive on the outside? It's going to go down. It's going down, right? So let's keep going, all right? So in the next one, we still have absolute value of x, but now we're going to subtract a positive on the outside. So we chose the same x values, then the corresponding y's here, and then if we subtract 3 from all those answers, we get these results, and we can indeed confirm that notion that we subtract a positive on the outside and move the graph down, right? So those are the first 2 transformations. We add a positive on the outside and moved it up. We subtracted a positive on the outside and moved it down. Okay. So again, let C be positive, then the graph of f of x plus c is basically the original function shifted c units up. And if we subtract that positive c on the outside, then that's going to be the original function shifted c units down. All right. So those kind of follow our intuition. So then, if we can do manipulations on the outside of the basic function, what can you anticipate the next one being? Instead of being on the outside, we can be on the inside, right? Inside manipulations. So if outside manipulations cause a vertical change, then that should kind of prime you to give you a sense of what do you think might happen if outside manipulations cause a vertical change, then inside manipulations we can anticipate a horizontal change, right? Let's see what happens. So I want you to think, like, if you had to guess, if we subtract 2 on the inside, which way do you think it's going to go? Which way do you think it's going to go? To the left by 2 or to the right by 2? All right? Is this one going to go left by 3 or right by 3, right? Okay, let's see. So now we're letting our basic function be x squared. And then we're going to do this minus 2 on the inside and the plus 3 on the inside, all right? So then if we choose these x values, we find these corresponding y's in the basic function. Then if we do minus 2 on the inside, notice the first one's this is gonna be 36, and then it's gonna kind of follow like this. I think you know how to generate these numbers. So notice we kind of have this green arrow effect thing going on, right? Everything was kind of shifted on the diagonal like that. If we plot the points for the green and the red, notice when we subtract the positive on the inside, you might think it goes left, which is the negative x direction, but it's actually going to do the reverse. So subtracting a positive number on the inside did the reverse of our intuition, and it went to the right by 2, right? Adding a positive on the inside moved it to the left, right? So the inside manipulations are horizontal manipulations, and they tend to be the reverse of our intuition, okay? Now, normally I would probably let you guys go in a few minutes, but we need to go all the way until like about 50. So we need to go for about another 14 minutes or so. Let's see. Mr. Reed, it's fine. Since I'm late, I'll let him in. Let me go like this, like this, like this. I'm gonna just mark him as late though. Okay. And I'm gonna have to restart this now. I think we left off here. All right. So again, inside manipulations cause the horizontal change, and they kind of were the reverse of our intuition. Even though we subtracted a positive on the inside, instead of going left by 2, it actually went right by 2. Okay. So all 3 functions are squaring functions, which are parabolas. So here, the first one, the x-intercept is 0. But then when we subtracted the 2 on the inside, the x-intercept was 2, right? So for each xy on the graph of f, there will be a corresponding x plus 2 on the graph of g. The graph of G is the graph of F shifted 2 units to the right. Okay. So the h-intercept here is -3 for this one. So same kind of deal, right? It was kind of the reverse of what we anticipated. Okay. Let's just close you out. You always do better when I reboot you. Okay, I'm watching the clock. I see the time. Okay. I think we left off here. Okay. So then now, so we've gone through a vertical shift. Now let's talk about horizontal shift, right? So again, if our C is positive, the graph of f of x minus c is basically going to be the original graph shifted c units to the right. If we did f of x plus c, it's the original function shifted c units to the left. C unit. Anyway, all right. That's actually, I didn't really want to go much further beyond that today. Oh, let's try this example. Let me see. Okay, I mean that's actually okay. Let's we'll go ahead and start with this slide for the day, and we'll just pick up here next time. So that's about where I wanted to be. Anyway, so okay, guys, let me do like this so you can unmute yourself if you want. All right. So yeah, we'll pick it back up tomorrow at 3:50, and we'll just kind of keep going from here. I'll go ahead and make a copy of this available, and yeah, we'll just pick it up next time. All right, guys, take care. See you.
Hi, everyone. Hey, up, Professor.
Yep. Take care. So let me see. Here.
Hi, Professor.
Take care.
Hi, gang.
Stopped here. What's the day? Monday, September 21st.
I had a quick question.
Go ahead.
How do we know, like, how much Alex to do, like, and when it's actually due?
Let's just go ahead and say that it's due Saturday, every Saturday at midnight, because my colleague says she's gonna just do a weekly report. She's gonna check it weekly. So as long as you're consistent, it'll be fine. And then, what level are you at?
Oh, that's another question that I was gonna ask. Like, how do we like know what level to do?
You just pick up wherever you left off on Alex. So wherever you are, if you've already done the placement, then just kind of keep going. At a minimum, everybody should be doing about 25 topics per week. But if you're like on the prep for intermediate algebra, then you need to be doing about 35 topics per week. And if you're at the prep for basic math, you need to be doing about 50 topics per week.
Okay.
And the goal is by the end of the semester for everybody to be at or above prep for college algebra.
Okay.
Okay?
Thank you.
Yep, my pleasure. Thank you. Start here Tuesday. September 22nd. All right, and let's go like this. Let's go like this.